like that. And action.
All right, today's lesson is going over multiplying, dividing, adding, and subtracting radicals. Okay, in order to do this well, you need to know your perfect squares through 400. I want you to list them out here. There should be 20 of them, and being the super nice person that I am, I'm going to give you the first one, which is 1, and I'm going to give you the last one, which is 400. I know, no need to thank me, okay? Make sure you fill in everything in between. Do not forget, your teachers will not accept this. All right, so we're going to look at multiplying first. There are 2 ways that you can look at multiplying radicals. If the radicals that you're given cannot be simplified inside, meaning there is no perfect square that goes evenly into them, then what you have to do is you have to multiply first. So 3x times 6x is 18x squared, and that's under the radical. Then you need to look and see if anything can be simplified. The biggest perfect square that goes into 18 is 9, so you break this up into root 9 and root 2, and then x squared is also a perfect square. The square root of 9 is 3. The square root of 2 has nothing else that can go into it. It stays just like that. And the square root of x squared is x, which joins the 3 on the outside of the radical, and you are done. You guys should remember this. This shouldn't be brand new information, but just as a nice review for you. Okay, so that's the first way. When you can't simplify anything under the radicals, you must first multiply and then simplify. All right, the second type of multiplication problem you're going to see is where the numbers under the radicals can be simplified on their own before multiplying. So you're going to simplify and then you're going to multiply. The square root of 8x squared. The biggest perfect square that goes into 8 is 4, so I'm going to break this up into root 4 and root 2. And then I've got that root x squared as well. Square root of 4 is 2. Square root of x squared is x. And then you've got that root 2 left over. Then you look at the square root of 12x to the 5th. Let's put it over here. The biggest perfect square that goes into 12 is also 4. You're left with a 3. And then x to the 5th, remember perfect squares in exponents are even numbers. So the biggest even number before 5 is 4, so I'm going to make this x to the 4th, and that gives me 1x left over. We have root 4, root 3, root x to the 4th, and root x. The square root of 4 is 2. The square root of x to the 4th is x squared, and then you've got 3 and an x left under the radical. Remember that you're still multiplying these. Okay, so now we do exactly what we did in the first problem, but we're going to multiply the outsides together. 2x times 2x squared is 4x to the 3rd. Then we're going to multiply the insides together. 2 times 3x is 6x, and that remains under the square root. Double check and make sure there's nothing that can be simplified under the radical, and you are good to go. Let's move on to dividing. When you're dividing radicals, again, there's 2 ways that you can look at this. The first way is to simplify the fraction under the radical and then break up the radical. Here's what I mean when I say that. Instead of looking at this as the square root of 10 and the square root of 8, I'm going to focus on the 10 over 8 and reduce that as it stands. 10 over 8 can be reduced by 2, and you get 5 over 4 under the radical. Then you're going to break it up into the square root of 5 over the square root of 4. Then we simplify from there. The square root of 4 is 2. The square root of 5 has no perfect square that goes into it, so I just keep it square root of 5. And you're done. That only works if the numbers under the radical can be reduced. Okay? Then you'll get cases where you can't reduce it, and that looks like this. Square root of 3 over 8. 3/8, they have nothing in common, so you go straight to breaking them up, and then you're going to look to simplify. This is the square root of 3 over the square root of 8. Okay? Square root of 3 can't be reduced, so we're going to keep that there. And now there are a couple different ways to look at this square root of 8. There is a perfect square that goes into it. Perfect square that goes into it is 4. This breaks up into root 4 and root 2, and you get 2 root 2 in the bottom. Now this, you wish was your final answer. Unfortunately, it is not, because you cannot have a radical in the denominator. We need to get rid of this. We do that by making it a perfect square. You need to think, what number can I multiply 2 by to get it to be a perfect square? And the answer is, I need to multiply by 2. 2 times 2 is 4. That's a perfect square. Here's what I mean. Let's bring this down here. Root 3 over 2 root 2. If I multiply the top and the bottom, remember what you do to the bottom, you have to do the top. Multiply it by the square root of 2. I get the square root of 6. Remember, 3 times 2, 6 under the radical. And then I get 2 root 4. 4 is a perfect square, so that can simplify to root 6 over 2 times 2, which is 4. And you are done. There's no radical in the denominator. This can't be simplified anymore. That is your final answer. All right, let's look at adding and subtracting. Don't forget to fill this in. You cannot have a radical in your denominator. If it's your final answer, this cannot happen. No radicals in the denominator. All right, for adding and subtracting, you must have common radicals. Just like when we combine like terms, you have to have like terms. Same thing with square roots. Let's look at this first problem. Two times the square root of 8 plus 4 times the square root of 8. The number under the radical is the same. That's what I mean by like radicals. So in this case, I can go ahead and add them. I have 2 root 8 and 4 root 8. 2 plus 4 is 6. And then that root 8 just comes along for the ride. Now you wish this was your final answer, but it's not. I'm really hoping you know the reason it's not. That can be simplified. Square root of 8 has a perfect square in it. And by now you should know that that's 4. This breaks down to the square root of 4 and the square root of 2. So I get 6 times 2 times the square root of 2, or 12 root 2. Done and done. Now let's look at a problem that don't have like radicals. 3 root 12 minus 3 root 3. I cannot combine these the way they are, but all hope is not lost. I can fix this guy right here. Square root of 12, it's got a perfect square in it, it's 4. This breaks down into root 4 and root 3. Don't forget about the 3 that was on the outside. So you've got 3 times 2 root 3, or 6 root 3. Let's bring down this guy, negative 3 root 3. I now have like radicals. So 6 minus 3 is 3, and then that radical 3 comes along for the ride. Okay, let's look at one more example. 3 root 5 plus root 20 minus 2 root 45. None of these are like. So do we just give up, skip it? Yeah, not so much. We see what we can simplify. This root 5 cannot be simplified, so I keep it the way it is. Square root of 20 breaks it down into root 4 and root 5, or 2 root 5. And the square root of 45 breaks down into root 9 and root 5, or 3 root 5. Don't forget to multiply times the negative 2 on the outside, and you get negative 6 root 5. So here's where we're ending up, and now I can combine. All of them have like radicals. So 3 plus 2 is 5, minus 6 is negative 1 root 5. Which brings me to the phrase of the day, which is it June 5th yet? Question mark, question mark, question mark. Is it the last day of school yet? Not so much. But that's okay. We've only got a couple more days. Good luck.